Hello and welcome to another science tutor lesson. My name is Nathan. I'm your tutor today, and in this video we're going to introduce or discuss three concepts: force, impulse, and momentum, as well as how they relate to each other. So from Newton's second law, which is what we're going to start with today, you should know that the force acting on an object, speaking of the net force in this case, is equal to the mass of the object times the acceleration of the object. So the magnitude of the force is equal to mass times acceleration. You should also be familiar with the fact that acceleration A is equal to change in velocity divided by change in time, or delta V over t, sometimes delta V over delta t. In addition, you may recall that change in velocity is equal to final velocity minus initial velocity, v minus u. So A is equal to v minus u divided by t. Alright? So just keep these in mind, or write them down on the corner of your paper so that you can follow along with the mathematics of this reasoning. So A is equal to v minus u over t. Let's substitute that into the Newton's second law. So we get F is equal to m times v minus u over t. And then we can take the m inside, multiplying both v and u, which gives us F is equal to mv minus mu divided by t. Alright, so let's look at what we have here now. The force acting on an object is equal to mv minus mu divided by t. Now, the mass of an object, m, times its velocity at a point in time, v, is a concept called the momentum of the object. The momentum of an object tells you about how much motive force it contains, or in other words, the amount of motion that is summed up with this object. It's not really a force per se. The momentum just is the product of the mass of an object and its velocity. So for two objects moving at the same velocity, one with a larger mass will have a much larger momentum. Right? So a mosquito and a tennis ball can be moving at the same speed or the same velocity, but since the tennis ball weighs so much more, in most cases, the tennis ball will have a much larger momentum. Right? So mv is equal to momentum. If mv is equal to the momentum at one point in time, mu, the mass times the initial velocity, will be equal to the momentum at some other point in time. So let's call that initial momentum. Alright? Following that reasoning, mv minus mu is equal to change in momentum. Alright? So this part up on the top of our equation is the change in momentum of the object, sometimes called or represented by the symbol delta p. So what this equation is telling us is that another way of stating Newton's second law is that the force on an object is equal to the change in momentum divided by change in time, delta p over t, which is equal to the rate of change of momentum. So Newton's second law can be stated as force acting on an object is equal to the rate of change of momentum. Now, if we take this equation, F is equal to mv minus mu over t, and put it on this side of our screen for now, then we can get another physical quantity from it. And to do this, we multiply both sides of our equation by t. So F times t is equal to mv minus mu, and here it would be divided by t multiplied by t, because multiplying by this additional t right here, so these two will cancel. So we get F times t is equal to mv minus mu. Now this quantity F times t is often referred to as the impulse acting on a material. And the impulse is just a measure of how long a force acts for. So if you give someone a quick push, in other words, the force that you give them acts over a short period of time, then you'd say that that force exerts or produces a smaller impulse than if you had exerted that same push over a longer period of time. Right? So impulse is equal to F times t. Impulse is also, from this equation, the change in momentum, mv minus mu. So the change in momentum is equal to impulse, and the force acting on an object is equal to the rate at which momentum changes, which, as you can see, is the rate of change of impulse. Alright? So impulse refers to F times t. It's a measure of how long a force acts for. So if there's anything in this video that was unclear, please feel free to review the video. You can also leave us a comment in the comment section below, and like or share the video if you found it helpful or interesting. Alright? So please stay tuned for the next video, and thanks for watching.